Okay, so just to wrap up, we have now found 495. This is one that works.
Yeah.
But the question is we don't know that this is the smallest yet, and especially we don't know that it's the smallest positive one. So let's see if we can figure out if it is. Okay, now you were going to say something about 0.
So it's 0 works. You have series of 9, 10, and 11 consecutive integers that make 0 viable here, but it says it's positive, so it doesn't actually work.
Okay, show me the ones that would work for 0.
So for 9, you can go from -4 to 0 to 4. Sum is 0. For 11, you can go from -5 to 0 to 5. Sum is still 0. And for 10, you can go from -4. Wait. It's minus 5. -5 to -1. Actually, 10 doesn't work.
Why not?
Because you can't skip over the 0.
Okay. What was our What was our condition that the number had to satisfy?
So it'd be a sum of 10 consecutive.
Can you tell me what our condition was?
10 consecutive integers.
But what did we learn from that?
Well,
About the number. What was the conditions about the number?
that had to be positive.
Any more?
And it can't be, it's divisible by 5 and not 2.
Okay, so what were the conditions of the number?
So it had to be divisible by 9, divisible by 11, and 5, but not 2.
Okay, good. Good. Those are the conditions we found about the number. Divisible by 9, 11, 5, but not 2.
Yep.
Does 0 satisfy those conditions?
It does not because
0 is technically divisible by 2.
Is it also more than technically divisible by 2?
Yes.
Yeah. Okay. So 0 actually meets the 9 and 11 condition, but
You
what?
can't meet the 10 condition.
It can't meet the 10 condition. Okay, but that's all right. It was a good try. So our question now is, we just discovered that 0 doesn't work actually. So that's okay. But we still needed a smaller positive number. So is there a smaller positive number, smaller than 495, that's divisible by 9, 11, and 5, but not 2?
No.
Okay, why not?
Because these numbers are all relatively prime to each other, so their least common multiple is going to be just the product of the numbers,
Okay.
which is 495. So you can't go smaller than 495 and still be divisible by all of these numbers.
Okay, so why don't you write down what the prime factorization of the number has to be at minimum?
So at minimum it has to be 3 squared times 5 times 11.
Okay. Because it's divisible by 9, so it has to have a 3 squared in it. Divisible by 5.
5 and then...
And divisible by 11. And it cannot have a 2 in it.
Yep.
And 495 equals this.
Okay, so there we go.
Yep.
There we go. Now, if the condition was altered, I was going to say, if it didn't say positive, then minus infinity is the answer, I suppose. What is, as you count backwards from 0, minus 1, minus 2, minus 3, what's the first number you're going to encounter going in that direction that's divisible, that meets this condition?
This divisible by 9, 11, and 5.
But not 2.
Not 2.
So maybe negative 495?
Yeah. Minus 495.
Okay.
So there we go. All right, good project, guys, and another good one from Matt Enlow. And all right, good work. High five.